Now let us tackle question 11, vectors and matrices. Given the vectors OP equal 3, 4, vector PQ equal negative 1, 2, and RS equal 1, 3, determine the vector OQ. So we know that vector PQ can be expressed as vector OQ minus vector OP. So let's sub in the values over here. PQ is 3, 4. OQ we don't know. OP is 3. So PQ is rather negative 1, 2. So PQ is negative 1, 2. OQ we don't know. OP is 3, 4. So vector OQ, let's group like terms, or let's group the vectors that we know at one side. So this becomes plus 3, 4 is equal to vector OQ. So our vector OQ is equal to, now when we add vectors, we add a corresponding component. So negative 1 plus 3, then we have 2 plus 4. So this implies that we have 2, 6. Vector OQ is equal to 2, 6. Now we are to show that OQ is power to RS. So OQ can be rewritten as 2 outside, then 1, 3. But 1, 3 is vector RS. Hence, OQ is power to RS because one can be expressed as the scalar multiple of the other. X, Y, Z is a triangle and M is the midpoint of XZ. So let's draw that triangle. So this is X, Y, Z. Now let's call this M. XY equal A. YZ equal B. These are vectors. We are supposed to express the following vectors in terms of A and B. Vector XZ. We know XZ is equal to vector XY plus vector YZ. So this will be equal to A plus B. Vector MY. So let's connect this. So vector MY will be equal to MZ plus ZY. So this will be equal to MZ plus, we don't have ZY, but we have YZ, which is the negative of YZ. MZ is also half of XY. Half of XZ. So we sub in A and B. 1/2 A plus B minus B. So we simplify this. So this will be equal to 1/2 A minus 1/2 B. So this can be rewritten as 1/2 A minus B. the matrices A and B are given as this. Determine A inverse of A. If you have the matrix A, B, C, D, the inverse of this matrix is given by 1 over the determinant, which is AD minus BC times the agent. The agent is D negative B negative C and A. So A inverse is equal to 1 over 2 times negative 1 minus 3 times 0 times 2 0, that's negative 0 is the same as 0, then negative 3 2, sorry, negative 1. One rather. Now we simplify this to obtain negative 1 over 2 times 2 0 negative 3 1. So this will simplify to 2 over negative 2 0 over 2 negative 3 over 2 then negative 1 over 2. So this will give us negative 1 0 then 3 negative we have 3 over 2 So this is over negative 2. Then so this will give us 1 over 2. So this is negative 1. Now this is the inverse. We are supposed to show that A inverse equal A inverse times A equal the identity matrix. So you have A inverse three over 2 1 over 2 times this matrix negative 1 0 3 2. Now this will be equal to negative 1 times negative 1 so this by this we go this first row take the first column, then later on take the second column of the second matrix. So plus 0 times 3. Then we have negative 1 times 0 plus 0 times 2. Then we have 3 over 2. So this time you're going to the second row of the first matrix times 3 plus 1 over 2 times 2 plus 1 over 2 times 3. So 3 over 2 times negative 1 rather times negative 1 then plus 1 over 2 times 3. Then this will take as the last one, which is we have 3 over 2 times 0 plus 1 over 2 times 2. So we simplify this. This will give us positive 1. This will give us 0. This will give us 0. Well, this is negative positive. Then this will give us 1. So this is the identity matrix. We are supposed to determine a matrix A squared. So negative 1 0 3 2 squared. So this is the same as negative 1 3 0 2 times negative 1 0 3 2. So by matrix multiplication we have this negative 1 times negative 1 plus 0 times 0 plus 0 times 3. Then we have -1 times 0 plus 0 times 2. Then we have 3 times -1 plus 2 times 3. Then we have 3 times 3. 3 times 0. 3 times this 0 plus 2 times 2. So this will give us 1 over here, then 0 over here, then 3 over here. This will give you 6 minus 3. So 3 over here, then 4 over here. Explain why the matrix product AB is not possible. So we know A is a 2 by 2 matrix. Then B is a 3 by 2 matrix. Now, for the multiplication AB to be possible, then the inner product must be the same. That is, the rows of the second matrix should be equal to the columns of the first matrix. But because this is not the same, it is not possible. It's not possible. So the row of the second matrix is not the same as the number of columns of the first matrix. That's why it's not possible. Now, without calculating, say the order of the matrix product BA. So we have B, the dimension is 3 by 2. Then A, the dimension is 2 by 2. So BA is possible. So this is equal to this, so it's possible. Now the dimension or the order of the second matrix is 3 by 2. 3 by 2 matrix.